Even though when you work with Samsung products, you predominantly think about ductless systems, a wall mount or a cassette that has no ductwork associated with it. There are specific units, and they are utilized more than you might think, that use ductwork. Whether that's a small pancake style unit that has minimal amount of static pressure for ductwork, a larger, thinner pancake style unit which is utilized for higher static pressures, or a traditional vertical or multi-position air handler that looks just like a unitary product. They do have ductwork. And one of the biggest problems we see with those is people's lack of knowledge on how to size the ductwork. So we're going to walk through doing some duct sizing and show you some duct calculators and the pluses and negatives of both. The first thing I want to stress is to know how to size ductwork, you really need to have a good understanding of ACA Manual D for duct design. You can pick up that manual from ACA on their store. You can also pick up a book that explains how to use it in more layman terms and less engineering terms. Both are extremely helpful for understanding how to design a duct system. So, with that being said, you need to understand how to design it. We're going to talk a little bit about the key component to using a duct calculator is the friction rate that you have to use. It is very rare that any two jobs will utilize the same friction rate. There have been misnomers in the industry that you design all ductwork at a 0.1 friction rate or a 0.08 friction rate. Both of those couldn't be more wrong. Every single job, the friction rate will vary based on the total effective length of the ductwork, the types of fittings and transitions that are used, the types of filters that are used which create a pressure drop, the grills, and any other item like a damper that might be placed in the air stream will cause a pressure loss. And we have to account for all of those before we set our friction rate. Once we set our friction rate, we can start utilizing a duct calculator. Now there is a formula in ACA Manual D that will tell you how to use your duct calculator. And essentially you start off with the manufacturer's rated static pressure. Whether that's a 0.2 total external static pressure, a 0.5 total external static pressure, or a 1.0 total external static pressure. Those are the common values you'll see that you'll start with. That does not mean you will use those values to set friction rates. Those are total external static pressures, and we need to convert those to friction rates. To do that, we have to measure the pressure losses of any device that's in the system and deduct them from that total external static pressure. So if you have a filter that has a 0.10 static pressure or pressure drop, you deduct that. Dampers that have a 0.03, grills that have a 0.03, you must deduct those from your available static pressure. Once you do that, you're going to come up with your available static pressure by deducting pressure losses and also calculate the rate by taking the available static pressure times 100. Then you'll divide that by what they call the total effective length. And that's the effective length of the longest supply run and the longest return run. Because if we can get airflow to the longest supply and pull air back from the longest return, we know we can get it to simpler zones. Now, total effective length is not just the linear length, it's the effective length of any fitting that changes. If you're using a 90-degree elbow, that might have an equivalent length of 30 feet of ductwork. If you're using a hard bend in a 90, that might be in a total effective length of 90 feet of ductwork or 120 feet of ductwork. So for that, you really have to go to ACA Manual D to gain a good understanding of effective lengths and pressure drops associated with devices. Once you have that and you calculate your friction rate, it's really easy to grab a duct calculator and move forward. There's various types that are out there. Most technicians like to carry this style of duct calculator with them. It's a small cardboard duct calculator that fits in a shirt pocket or in a folder, a metal clipboard, and you can slide it around and set your values. Challenge with these type of duct calculators is that 98% of them only work on metal duct. If you're doing metal duct, you can use this as much as you'd like. But if you're using flex duct or duct board or internally lined duct, this duct calculator will give you the wrong sizes for the duct system all the time. So it's preferred to use a duct calculator that's designed for multiple styles of duct material. This happens to be the duct calculator produced by ACA, the Air Conditioning Contractors of America, which is the organization that produced or wrote Manual D for duct sizing. There's a lot of great information on here. This duct calculator is available in this form, which you can carry with you. They make electronic versions as well. Whichever you prefer is yours. Notice the difference on this duct calculator is unlike the other, which only did metal duct. This one here will do galvanized metal duct. which is for straight metal duct, right? It'll also do wire helical flex duct. This is going to be your traditional flex duct with a spiral core wrapped in insulation on the exterior. We also have two more scales on the front of this chart. One for duct board, which is insulation made out of pressed fiberglass making a board, or duct liner, which is internally lined duct. This will give you the proper CFM based on what they call the internal roughness factor of each type of material. So in this example, let's say that you did your available static pressure setting and you came up with an appropriate friction rate for your system. And in this case, we say your friction rate was a 0.08. If you look at these blue charts here, you notice on the one side they say the type of material, galvanized metal duct. If we go to the far other side, it tells you the friction rate per 100 feet. And when we do the friction rate formula, we're reducing it to 100 feet for our equations. Wire helical flex, again, friction rate. Duct board, friction rate, duct liner, and friction rate. So what we're going to do if we need to size ductwork is we're first going to set and find our friction rate. In this example, we're looking at a 0.08 friction rate. Now we need to know how many CFM are we going to move and what size duct we'll use to do that. Straightforward and very simple. This grayish color here in the center with the white line, this is your volume in CFM. If you know you have a 5-ton system and you know you're trying to move 2,000 CFM of air, it's that simple. Take your friction rate at a 0.08 and line that up with 2,000. Just simply spin the chart. And you'll see now I have a 0.08 friction rate, which is what we calculated, and we're trying to move 2,000 CFM of air. Now all you need to do is come down here to this area right here and look at round duct diameter. And you'll see with the arrow pointing up, it's showing about a 19. You're not likely going to find a 19-inch round duct. So you would increase up typically to a 20-inch duct or decrease down to an 18, depending on the velocity of the air. We need to make sure we're maintaining minimum velocities, and this duct calculator will calculate velocity for you as well. It just does it on the opposite side, which I'll show you in a moment. That's great if we know we want round duct diameter. If we want to use rectangular duct, we have these two scales in the center on the left and on the right. These two cells here, you can line up one dimension with another to design your rectangular ductwork. This is telling you here that the equivalent of a 20-inch duct, let's say we moved it up to a 20 because that's what size we could get or we needed for the velocity. It'll now tell you that on this example here, if I wanted a 12-inch duct, I would line up 12. The first number it would intersect with would be a 30. So to carry the same amount of air as a 20-inch round, I could use a 12 by 30 duct. I could use any other combination in between. Let's say that I wanted a 16-inch duct. I would find where that intersects. That intersects with the line that's just below it. If I follow the line over to the right, it would be a 16 by 20. That would be the equivalent of a 20-inch round duct, and it would give me the CFM I need at that static pressure that I'm designing for. Now, let's say that you've run the system. You've taken 1,000 CFM of air away by taking off branch ducts. Now you need to reduce your plenum size down to handle the 1,000 CFM, but you're still using the 0.08 friction rate. Now I would simply take my 0.08 and this time slide it over to 1,000 CFM. My round size here comes out to be about a 14, and then I can use any other rectangular value there. Some people may be thinking, wait a minute, that's way too big of a duct. But remember, if you were using this duct calculator to size flex duct, it's not the same as using this duct calculator. These duct calculators account for the internal roughness of the material you're installing, and it adjusts its friction rate accordingly. This procedure I just showed you would be the same for galvanized metal duct, wire helical, duct board, or duct liner, but they're all going to yield different sizes at the specific CFM. So let's go a different way with this. You looked at a job that's already installed. You went ahead and got the pressure drops of the associated devices, found out the manufacturer's total external static pressure, calculated the total effective length of the longest return, the longest supply, and this time you calculated that the friction rate needs to be a 1.0. You're not installing the ductwork, you're just evaluating it. So in this situation, you walk into the room and you realize that there's a 6-inch duct feeding air into that space. Let's go backwards. This time we're going to take our round duct diameter and we're going to adjust it to 6-inch. By calculating our friction rate, we know we need a 0.10 friction rate. So I'd come up to 0.10 and I would look straight down. Here's my 100, here's my 120. So I'm probably somewhere around 115 to 117 CFM is going to come through that size duct with galvanized metal duct. If I'm looking at wire helical flex, it's going to be different because here's my friction rate for wire helical flex. A 0.10, I'm going to come straight up, is only going to give us 80 CFM. Same size duct, 6-inch. Galvanized metal duct, 0.10, going to give me about 115 to 117. Wire helical flex at a 0.10, it's only going to give me 80. This is why you cannot use the same duct calculator for different materials. You need to account for that internal roughness. Okay. As we look at the back of the duct calculator, there's various scales as well. And the key thing you want to look at here is you want to look at the velocity. Here's the volume in CFM in the blue scale. Here's the duct height and length. So what we'll say here is that you had, from your other side of your chart, you knew that you were moving 300 CFM. Let's see here. We would take our rectangular square area or our duct height and width. For this example, we're going to take our duct height and width and we're going to set this to a 10 by 15 duct. So here's our duct height, our duct width, 10 by 15. We know that in that specific duct, we may be wanting to move 1500 CFM of air. Look directly below at the velocity. And from there you can see that that 1500 CFM is going to yield 1500 feet per minute of airflow. Way too excessive. Okay? So I could change to a different size duct with the same volume, and that would further reduce my velocity. Now this has just been a high-level overview. There's many more things you can do with a duct calculator. But if we understand the basics of selecting a friction rate and then adjusting that friction rate on our duct calculator as needed, we can size our duct systems effectively and appropriately, and also use the duct calculator as a troubleshooting tool to make sure that we have the right ductwork to carry the right volume of CFM. Hope you found the video informative, and thanks for taking the time to view it.
For service manuals and other documentation, please visit our website at samsunghvac.com or use our Samsung HVAC mobile app to download any technical documentation. Thank you.